climate cycles influence life on our planet. Today, the world faces the threat of irreversible climate change. The reality of extreme weather. In India, 60% of agricultural land is still irrigated by rains. The monsoon remains right at the top of the list of concerns for the people of India. From this realization emerged Indian Institute of Tropical Meteorology. This premier research institute generates scientific knowledge in meteorology and atmospheric sciences that can be critically applied in vital areas. Established in 1962 at Pune by the Government of India with the support of World Meteorological Organization and nurtured by its founder-director Professor P.R. Pisharoti, a renowned physicist and remote sensing scientist. Today, IITM focuses on basic and applied research in atmospheric and oceanic sciences with emphasis on monsoon variability and predictability. Functioning under the Ministry of Earth Sciences since 2006 and executing through the Earth System Science Organization ESO since 2007, IITM is the nodal research organization to study and understand the mechanism of monsoon, weather systems, and climate-related processes in the tropical region. Through partnerships and collaborations, the Institute brings in the finest of global scientific advances to update its technologies and knowledge base. Against the backdrop of global warming, the Institute's modeling techniques help evaluate monsoon changes under various climate scenarios to plan water resources and disaster mitigation. Launched in 2012 and funded by the Ministry of Earth Sciences, Monsoon Mission aims to develop dynamical models to improve prediction of weather and climate in general, and the Indian summer monsoon in particular. A state-of-the-art dynamic simulation and prediction system has been developed for monsoon rainfall on short-range weather prediction, extended-range prediction of active or break spells, and seasonal prediction with reliable accuracy. In-house ocean data assimilation system is also being set up. This monsoon mission model accurately predicted the excessive monsoon of 2013 and the strong El Nino-influenced deficient monsoon of 2015. Extended-range predictions are also now available for heat waves, information useful for the public as well as policy makers. In 2015, AirPass, one of the mission's applications, was awarded ISO 9001-2008 certification. To probe monsoon against the larger backdrop of the challenges of global climate change, IITM has established the Center for Climate Change Research. The center operates from this eco-friendly green building and explores new areas of research to understand the Earth's climate system, measure greenhouse gas emissions, and generate regional climate change projections. An Earth System Model, ESM, has been developed at this center as an important step towards generation of global and regional responses to long-term climate variations and climate change. IITM, for the first time from India, will contribute to the forthcoming IPCC 6th phase of Coupled Modeling Intercomparison project using IITM ESM. The Centre is also leading an international program, CORDEX, on high-resolution improvised projections of regional climate for South Asia required for impact assessment studies. Monsoon variations in centennial and millennial timescales are tracked through paleoclimatic studies by analyzing various records such as tree rings, coral, cave deposits, etc. Under the INDOFlux program, the Centre has set up 3 sites to measure fluxes of energy, carbon dioxide, water vapor, and methane over different ecosystems. The accuracy of weather and climate forecasts significantly depends on how well clouds are simulated. For this, IITM has a major project on physics and dynamics of tropical clouds. Cloud Aerosol Interaction and Precipitation Enhancement Experiment, CAIPEX, is India's first national airborne experiment to study clouds, aerosols, precipitation processes and rain enhancement. Since 2009, 820 hours of airborne observations probing a variety of clouds under different conditions over India have been completed. For in-situ observations of aerosols and clouds, a high-altitude cloud physics laboratory, first of its kind in India, has been commissioned in 2014. State-of-the-art instruments including X and Ka band weather radars are now operational. IITM Delhi branch maintains precipitation and aerosols chemistry network of about 11 stations over the Indo-Gangetic plains. A lightning location network is established over Maharashtra to investigate electrical characteristics, dynamics of thunderstorms, and develop lightning climatology maps to identify most lightning-prone regions of Maharashtra. Effects of electrical field on cloud drops are simulated in the lab for cloud microphysics studies. A fluid dynamics laboratory has also been established to investigate convection, cloud flows, and boundary layers. Metropolitan air quality and weather forecasting services. System of Air Quality Forecasting and Research, SAFAR India, has been indigenously conceived, developed, and commissioned by IITM Pune for Indian megacities. Environment-specific, customized meteorological and air quality products are disseminated through LED display boards, mobile apps, news frames, web portal, and interactive voice response services for public awareness. Suffer India is India's first air quality forecasting system that has been awarded ISO 9001-2008 certification and international recognition by World Meteorological Organization, United Nations. A national network of modeling air pollution and networking, MAPAN, of 15 air quality and weather monitoring stations are operational throughout India. MAPAN provides baseline data for Suffer's regional air quality model for the Indian domain. The data generated through Suffer and MAPAN networks serve the strategic hypotheses-driven science plan, which adds significant dimension to the vision of IITM. IITM's path-breaking work is made possible by its people, infrastructure, and support from the MOES. IITM has a highly qualified and committed workforce of dedicated administrative staff and scientists. More than 80 PhDs have been produced by IITM since 2006. IITM scientists publish over 150 papers annually with a cumulative impact factor of over 350 in Science Citation Index journals. For 2015-16, in the prestigious Nature Index ranking, IITM occupied top position among Indian institutions in earth and environmental sciences. High Performance Computing Facility. The Institute's High Performance Supercomputing Facility Aditya, ranked second in India, is used for research, development and forecasting to cater to the computing requirements of MOES organizations. Capacity building programs for India at IITM. A Center for Advanced Training in Earth System Sciences and Climate, CAT-ESSC, was launched in 2010 at IITM to identify young talent from various streams of science and engineering and train before absorbing them as junior scientists in various organizations of the Ministry of Earth Sciences. The MSc, MTech, and PhD programs in atmospheric sciences of Savitribai Phule Pune University are conducted at IITM. IITM also hosts an Office of the International Climate Variability and Predictability, CLIVR, Monsoon Project Office, ICMPO since 2015. Modern infrastructure plays a crucial role in backing up IITM's quest for cutting-edge research in earth sciences. Beyond these corridors, the dedicated teams of IITM are decoding the challenges of global climate change and the mysteries of Indian monsoon. People, knowledge, technology, integrating them for a focused scientific objective. Here, the precepts and techniques of science are focused to mitigate unpredictability and to support the aspirations of India.
It is our vision to make IITM a global center of excellence through basic research on all aspects of the tropical ocean, atmosphere, land, coupled system required to improve weather and climate forecast. However, we are also reminded by nature from time to time that there are grand challenges faced by our society. Like we had the recent flood events, Uttarakhand and Chennai, which created huge impacts, devastating impacts on human lives, on the economy and so on. So to address this grand challenge, our plan is to develop innovative scientific strategies, infrastructure development, building the human resources within the country, and developing a collaborative approach by involving the universities, the academia, the research institutions to address these grand challenging issues.